label some chiral carbons. So a chiral carbon is going to be one that has 4 different groups attached to it. So if we go down here, we can see that this carbon, if I were to expand that out, that CH3 means he has 3 bonds to hydrogens, and then he's got 1 bond over here to this carbon. So that's not 4 separate groups, 4 different groups. 3 of those hydrogens are exactly the same. So anything that has like a CH2, CH3, that cannot be chiral. So this one's not chiral, this one's not chiral. This carbon here, let's see. This carbon has attached to it this ethyl group. It also has a bond to the carbon that's part of this propyl group. So those are 2 different groups. Even though they're both, bonds to carbon, they're different types. There's, different number of carbons. It's not symmetric on both sides. So that's 1, 2. This guy has a hydrogen and a bromine. So that is definitely a chiral carbon right there. Just erase some of these. So that's a chiral carbon. This carbon is a CH2. That means it's got 2 hydrogens. They're not different. No. So just that one. Over here, let's look at this carbon. CH3, that's not going to be chiral. This CH3 is also not going to be chiral. So I look at this carbon, this next one, it's got a hydrogen, and then it has 2 methyl groups. So because it has those 2 methyl groups, they're exactly the same type of group. That's not going to be a chiral carbon. This middle one here has a bond to this group. It's got a bond to this group. It's got a hydrogen and a methyl group. So that is going to be a chiral carbon. It's got 4 different groups attached to it. So that will be chiral carbon. CH2, no thank you. That's not going to be chiral. If we move on over here, again, CH3 is not going to be chiral. This carbon, let's see, he's got a methyl group. He's got an ethyl group. He's got all this other stuff, as well as a hydrogen. Yep, that's going to be a chiral carbon. That one's chiral. This carbon CH2, not going to be chiral. Okay, CH, that's a possibility. So this carbon is attached to a bromine, a methyl. It's got this whole group and a hydrogen. Yes, so that will be chiral. So this molecule over here has 2 chiral carbons. Awesome. That CH3 is not going to work. Nothing in a, this is a benzene ring. If I were to draw that out, that's got like alternating single and double bonds, right? Another way to look at this one is alternating single and double. Once I have a multiple bond in there, that means I can't be bonded to 4 different groups. So that's none of those are going to be chiral. This carbon CH2, not going to happen for it. This carbon's not going to work. So really focusing on this one, this carbon has this group. It's got an amine. It's got a carboxyl group and a hydrogen. Yep, that's the chiral carbon. This one right here. Over here, none of those benzene, none of the carbons in the benzene or this methyl group or that methyl group. This one's not, this one's not, this one's not. So really, this is the only possibility. And that carbon has an ethyl group, a methyl group, hydroxyl, and all this other stuff. So yes, that will be the chiral carbon there. And over here, let's see, I've got a CH2, no, CH, yes, let's look at the CH. So he's attached to this group, all of that, and a hydrogen. Yep, that's a chiral carbon right over there. So this guy is chiral. This carbon has what attached to it? It's got an H, it's got an OH, it's got this whole group and that whole group. So this one is also a chiral carbon. This carbon has a double bond O, so nope, it can't. It needs to have 4 different groups attached to it. And this carbon has 2 hydrogens. Nope, that's not going to work. So that one only has 2 chiral carbons as well.